All right, friends and neighbors, welcome back to CCNA Volume 2, Chapter 2. We are going over basic IPv4 access control lists. So we'll do a bunch of examples, and I will include a whole bunch of content that is in other videos. But let's get started with access control lists. In this video, we'll hit the key topics for the chapter, and our exam section is the security fundamentals. And so right, we talked about in the opening, it's configure and verify access control lists. And in this particular video, we'll be talking about just what we call standard access control lists, or the access control lists that just examine the source IP address. And we'll finish up with the do I know this already questions. Key topics for this chapter: summary of the general rule of the location and direction for ACLs. So it turns out that we want to think about ACLs before we deploy them, and so we'll go over some of those ideas. Summary of the four main categories of IPv4 ACLs in Cisco iOS, and of course we're going to hit all of them in detail. This chapter focuses on the standard. Summary of first match logic used by all ACLs, and really what that means is you've got a bunch of filter rules. Which one do I go after first? And it is whatever matches first. And then we'll talk about wildcard masks. You can apply a wildcard mask to just about any ACL, and some of them are specific to a host, a subnet, or a larger address space. So we'll talk about those and go over some examples. And then we'll talk about if you were going to deploy an ACL, what are some steps that you might go through before you do it, right? Getting up, thinking about the data that you want to address or the packets you want to address, where is this ACL going to be, and so on. So we'll go over those ideas. And then how do you go about setting up the ACL filter rules themselves? Access control list basics. So what is an access control list? It's a mechanism to identify different kinds of packets. Now, the most common thing that we do is we identify packets so that we can do some security thingy with them. But what are you looking at? Well, when a packet comes in, you know that packets have an IP header. Well, in that IP header, there's a whole bunch of fields that we can use to identify those packets. We can look at the source IP address, we can look at the destination IP address, we can look at the protocol ID, we can look at the quality of service field. And then we have the headers at layer 4, right? So we can look at the TCP and UDP port numbers. And so there's a whole collection of fields that we can look at to identify packets. And the access control list, which is a list of rules, says, here's what I want to examine. Now again, the most common thing that we use these for is to identify packets so that we can do a security thing. We can say, I want to either permit or deny this kind of traffic. Well, access control lists, because they're just identifying packets, can be used in a whole bunch of other places as well. So two other common places that we use them are quality of service provisioning, right? If you want to write a policy on a router, or network address translation. Now, a really important idea is location and direction. So what that means is, where are you going to put this particular access control list? And so what happens is you take those filter rules and you assign them to an interface on a router. Well, another important idea on that same interface is which directions are the packets going. So on a particular interface, packets can come into an interface or out of an interface. And it makes a big difference which direction we're looking at. So what we'll talk about in our demo today is that we're going to identify traffic flowing from one side of the topology to another. And so the direction makes a difference. And if we apply our access control list in the wrong place or in the wrong direction, we will get unexpected results. So we want to think about that beforehand. Now, matching packets means that you wrote a rule like, I want to identify packets coming from a particular IP address. And so each packet that comes into that interface or out of that interface, depending on your direction, is matched against that list. So what you say is, all right, if I'm interested in the source IP address, what's the source IP address of this packet? What's the source IP address in the rule? And do they match? This is sometimes called the match criteria. And this can be just a particular value, or you can apply that value with a mask to get a broader range of packets. So the question is, do the packets look like any of the rules in the access control list? Now, once you've picked your interface and your direction and you've got all your match criteria, what do you do when a match occurs? Well, it might be that the traffic is permitted, right? I want this traffic to get to where it's going. Or you might say, that's not traffic I want on my network. And so in that case, you're making a decision to permit or deny. Now, the four basic types of ACLs, at least for the CCNA, are listed here on this slide. Now, it turns out that there's a lot of different kinds of ACLs, but the ones that we're worried about for this exam are really standard, extended, named, and then we've got some additional address space that or numerical space that we can use for these access lists. Whatever number you use identifies the kind of ACL that you're doing. So the minute you use one of these numbers, then the logic of the iOS says, oh, we're interested in a particular set of fields. So standard access lists use numbers 1 through 99, but can also use 1300 to 1999. Extended access lists, the minute you use a number between 100 and 199 or 2000 and 2699, then the logic of the iOS says, oh, I know that we're dealing with more fields. So a standard access list just says, I am interested in source IP addresses alone. And so remind you about the direction. So source IP addresses, if you're looking at that field, they only appear in a particular direction. Traffic coming back the other way will have that same IP address in the destination field. That's really important to remember. You can also do named ACLs. You don't have to go by number. You can do named ACLs, and then you get all your subcommands associated with them. And the chapter also mentions improved editing with sequence numbers. We'll talk about that in another chapter. And in the look ahead, we'll see that extended access lists are going to be what chapter 3 is all about. So standard numbered IPv4 ACLs, right? So these will be where you are identifying the ACL by the standard ACL numbers, right? 1 to 99, for example. All that we care about is the source IP address in the packets that you're seeing. So direction is really important because the source IP addresses for one direction will be the destination addresses in the opposite direction. So if you think about that for a sec, if I ping an address out on the network somewhere, when the answer comes back, it's an answer to me, which would be my destination. So if I was interested in my source IP address, I would have to pick an ACL to be applied in the outbound direction. Now, an ACL consists of actually two parts. There's the filter rules themselves, what you're looking for, and then applying the access list to an interface and direction. Now, the other thing that we talk about is first match logic. If you have a whole bunch of rules, I'm interested in packets that have this source IP address. I'm interested in this packet that has this destination IP address. The first rule that matches is the one that the iOS is going to act on. So it doesn't matter if you said, well, I really wanted this packet to match line number 4, but if there was a line earlier than that, that's the one that the iOS picks. It doesn't know which one you prefer. Our basic syntax is access list, and then the number, and then permit or deny, and then whatever our match parameters are. So let's go ahead and do a basic example here in our topology for today. So here is our packet tracer topology. Now this is similar to a lot of the topologies that are in the chapter. And what we're going to worry about right now is packets that are moving in this particular direction. So we're going to worry about sort of the 1 net to the 3 net direction. I haven't set up the routers completely yet. I've got them mostly working, but we'll take a look at what we have in the IP route statement. So there's our link specific routes, right? So here's our router IP addresses. I've labeled them on the diagram. And then we've got our 1 and the 2 net. So I need to build my static routes. So I wanted to start this topology sort of from the beginning so that there's nothing that was here before we started going over what we're going to do. All right, so I'm going to do my static routing for the two routers first of all. So I'm going to say IP route, and we're going to get to the 10.3.3 network in our mask. And I'm going to go via, right, because we're dealing with Ethernet interfaces, we want to make sure we use an IP address, 10.2.2.253. There we go. And I'm going to do the same thing on my neighboring router, but we want to get to the one net. So we're going to do IP route 10.1.1.0, 255.255.255.0, and then we're going to go via 10.2.254 in this case. Now, I like to do this every once in a while because it's good to do a review. It's good to remind us how all this stuff works. Now, I'm worried about traffic going, from the one net towards the three net. Now, if we address this router right here, router 0 or router 1, what does that mean? Well, we'd be looking at our 10.1.253 interface or the 10.2.2.254 if we're going to just talk about router 0. If I'm interested in permitting, say, 10.1.1.1 to get over to the 3 net, what's the direction that we're interested in? Well, it's clearly going from the 1 net to the 3 net. But what we have to realize is that the 10.1.1.253 interface has two directions. It has an in and an out. If I look at the out direction, well, that's traffic heading to the 10.1.1.0 network. So there's really two ways to apply an access list on router 0 if I'm interested in flow from the 1 net to the 3 net. I can send it in 10.1.1.253 or out 10.2.2.254. So let's take a look at some of our options that we have available to us with our access list. So if I say access list, and then I just do a question mark here, there's our numbers. Now, the minute I pick one of these numbers, I'm automatically led down a pathway for the fields that are specific to this particular kind of access list. So in the book, we use access list 1 quite a bit. And then now we've got this question of whether or not I'm interested in permitting or denying the traffic. Well, since I want to allow flow, I want to pick a permit statement. Now I'm going to permit, what am I going to permit? Well, the easiest example would be one particular IP address to match. And so you can see that there's some other keywords here. The host keyword is deprecated because the minute you use an IP address, that sort of identifies a host. I could do any, that's a very broad one, or I could pick a particular address. Now, since we're doing our first example here, I'm going to say, well, I just want to do 10.1.1.1. And what's next? Well, I could be done. I could be done, or I could apply those wildcard. I'm going to just be done right now, since this is our first example. Now, if I take a look at my running config, there's my access list right there. Now, this just has one filter rule or one access list rule. It's not doing anything at all right now. In order to make this do something, I have to pick an interface and direction. So let's go to interface G0/0/0. Now, that happens to be this interface right here. And what I'm going to do now is use the access group command to apply it. So I'm going to say IP access group 1, which identifies the access list, right? If we do that, it identifies the access list. And then what do? We're going to examine this in the inbound or the outbound direction. Well, if we're looking at traffic flowing from the 1 net to the 3 net, the only thing that makes sense is in. Well, let's take a look at what happens if I ping from 10.1.1.1 to 10.3.3.1. Now everybody's got an ARP, right, to update all of this. There we go. So that succeeds. right, now that the routers have ARPed and found everybody. And if we were looking at the simulation for this, we don't care about packet content right now. But if we look, right, it's standard transmission. You would have no idea that an access list is applied, right? It just goes across the network based on the routing. But what happens if I do the same thing from 10.1.1.2? So we know the routing works. Whoops. Okay, so we know this PC is alive. Now let's just take a look at what we see right here. This is a reply, not from the destination, not from itself, but from the router that says destination is unreachable. Well, what happened? So we're going to ping again, and we're going to slow things down a little bit. Goes out, there's the switch, there's the router, and the router says, you're not getting there. Now we know the router knows how to get to the 3net. But what did the router do in this case? The router said, I'm going to look at your IP address, look at my access list, and find out that you are not permitted. You are denied. Well, how does the router know that? Because my access list is just referencing one particular host. Well, what we have to remember is at the end of every access list is an implied or implicit deny all. In other words, if you're not permitted by an access list, you're automatically denied. Okay, let's go back to the slides and add a few more ideas. Matching logic. Well, what we just did is match the exact IP address. So the first line on this slide is exactly what we just did, right? Access list 1 permit 10.1.1.1. Now we could also have said access list 1 permit host 10.1.1.1, but that's a little redundant. Now those wildcards that we saw, it turns out that access lists have their own kind of mask. Importantly, it's not a net mask. It is a wildcard mask. So wildcard masks are a little more flexible than net masks, but they work in almost the exact opposite way. So in a net mask, where a binary 1 in the mask, or 255 means that you match whatever's in the address space. In wildcard masks, a 0 is a match, and a 255 means ignore. So if we were going to do access list 1 permit 10.1.1.0.0.0.255, that would match the entire subnet because this 255 says, I don't care about this last octet. This would be equivalent to a net mask of 255, 255, 255, 0. And then you can move on out, right? You can say, well, permit 10.1.1.0.0.255, 255, in which case, I don't care about the last 2 octets, and so on and so on. Now, just like a default gateway with net masks, all zeros means I'm going to ignore everything, and all 255s means match this particular IP address. A wildcard mask of 0.0.0.0 would match a particular IP address. We can use the keyword any, but that's letting everything through, so you got to be a little bit careful about it. So let's take a look at 2 more examples if we were going to address that other host on the OneNet. So if on our router, I said, I'm going to go back to our access list, and I'm going to say access list. Now there's going to be a couple things that happen here. We're going to see that editing access lists on a router is not always as easy as we would hope, but I'll cross that bridge in a second. We know that we have this rule. So what I'm going to do is add another rule to access list 1. And I'm going to say permit, and we'll say 10.1.1.2. Now I could do the wildcard mask, right? So if I said 0.0.0.0, this would match this particular host. It's effectively the same as saying this line right here. So there we go. Well, let's see what our config file looks like now. So I stuck in the wildcard mask, and I didn't use the keyword host. Now this version of the iOS in Packet Tracer retains the host, but if the host disappears, or if it's added, don't let that freak you out. It's the same thing that I typed in, right? Access list 1 permit a particular host. Notice also that the access list is not included the mask that's specific to a host because it's redundant, right? It matches that particular host. So now if we go over to our PC, it is now allowed. Well, let's do a couple of other things. I'm going to get, oh, and by the way, I was editing the access list and the access group command remained. So you got to be a little careful when you're manipulating your access lists and IP access group commands. So let's do this. I'm going to get rid of all of these. I'm going to say no access list 1 permit 10.1.1.1, right? And I'm going to do the same thing with 2. Now, if we take a look at our config file, right, I have no access lists. That doggone access group is still there. Now, the reason I did this is so that we can also use the any command. So I'm going to say access list 1 permit any. So even though access list 1 would have the deny all at the end, and I'm not addressing any particular PCs, let's see if these work now. So I can ping the destination from there, and I can ping the destination from there. Okay. Now what would happen if I said, oh goodness, I've forgotten I didn't want 10.1.1.2 to go anywhere. So I could say access list 1 deny 10.1.1.2, right? And we'll take a look at our rules. So I have these two rules. And you look at this one and you go, okay, I know that PC is not going to be allowed to go anywhere. So let's take a look if that's true. So we're going to try and ping the destination, and all of a sudden it is allowed to get there. What's happening? What's going on? Well, this is an example of first match logic. The first line that matches is the one that the router will listen to. And so this right here, this permit any, is matched before I get to the deny. Really, really important idea. So the reason that traffic is allowed to go through is because this line matches before the deny line gets there. So your order of rules makes a difference. Well, let's do one more example. I'm going to get rid of my access list. No access list 1. So we'll make sure that it's gone. Right? The access group is still there, but I don't have an access list. Now what I could also do is use those wildcard masks. Now we already saw one with a host. Let's do the subnet itself. So I could say access list 1 permit. We want to do the whole subnet. So 10.1.1.0, whoops. And then the wildcard mask that would apply to this is 0.0.0.255. So now if we look at these two hosts, can they both get there? They both can. And what would this line look like in the config? Right there. It's exactly what I put in there because this is not applied to a particular host or anything else. So there we go. There's the any keyword, there's the first match criteria, and we've got a wildcard mask for a subnet. Now, what if the subnetting is more complex? Breaking across the octet boundaries is pretty straightforward, right? If we do, an address space 0.0.0.255. If we do a larger address space, like a class B size 0.0.255.255, and so on. But it's very common, of course, that subnets don't break across the octet boundaries. And so you can use the very flexible wildcard mask to put in any pattern that you want. Now, here's the book example, right? The 172.16.8.0, but the mask is 255.255.252.0, which means that there's a weird collection of address space, right? It's not the 8net. It's actually the 8, 9, 10, and 11 networks. But wildcard masks are flexible, and if we remember that when we're looking at IP addresses and masks, we're actually looking at binary. Then we can break an IP address into its binary and the mask into binary, and we notice where the ones and zeros are. Now, in a net mask, the ones are the part that we care about, and the zeros are the part that we ignore, because anything ANDed with a zero gives me a zero. What we're going to do is turn that idea on its head to learn how to manipulate wildcard masks to do these more complex address spaces. So now we're going to figure out that sort of backwards wildcard mask by subtracting. So there's two ways to go about this. If I take the book example and I say, well, what if I start off with a net mask of 255, 255, 255, 255, and just subtract whatever the network mask is, and I would get the wildcard mask that I'm supposed to use. So in this case, right, the base 10 arithmetic is here, and the binary arithmetic is over here. So if I just subtract, right, 1 minus 0 is 1, 1 minus 0 is 1, and so on, and I get 1 minus 1 is 0, and all the way out. So this gives me the binary version of the mask, and then here's the base 10 version. Now that is a very nice way of doing this and figuring this out. Another way to do that is to just simply say, well, what's the net mask? Let's convert that to binary, and then just flip the bits. Turn the zeros into ones and the ones into zeros, and you get the same answer. Now, depending on what your address space is, one method may be faster than the other. This subtraction method is actually very, very fast because the numbers are things that we're used to dealing with, right? These particular values. And then we just type that mask in. Now you can also take the time to convert this to binary and then flip all the bits, but that can be a little more time consuming. So implementing standard ACLs. So what's the plan? How do you go about starting this process off? Well, step one, plan the location. Where are you going to put these ACLs? And in particular, what's the router interface you want to use and what's the direction? Now, standard ACLs should be placed near the destination to ensure that packets are not unintentionally discarded. Now, this is particularly true when you're dealing with deny statements, but what we have to remember is that there's that implicit deny all at the end of every statement. So anything that's not permitted is denied. So you want to think about where your ACL is going to be so that you don't block traffic by accident. One example that happens all the time in the lab is when we're setting up a routing topology using a routing protocol like OSPF, and you start to put ACLs up there and you think about the host traffic, but then you end up blocking your routing protocol. So what you want to do is think about your source IP addresses that move in the chosen direction and apply your ACLs accordingly. Step two, configure your global access list commands. These are the access list rules themselves. Keep in mind that sequential first match logic. We saw what happens if that gets out of order. And remember that no match means you get denied. And then the last step is, of course, to say, well, I've got all my access list rules. Now I'm going to do the IP access group command on the interface. Now, let's say you get yourself into trouble. What can you do to troubleshoot your ACLs? Well, a lot of it is just straight up practice and getting used to looking at it and getting used to thinking about traffic flow. So you want to think about your match criteria. What were you trying to do? Are we talking about source IP addresses, combinations of fields, and predict what your access list rule is going to do? You can also add the log command to your access list commands that would generate output to the screen or even send things to a syslogger. And then remember that you can take a look at your interface commands and your access list commands to get an idea of what's been matched, what's been dropped. And of course, think about that direction and interface you're going to use. All right, let's do a couple more really quick examples. So if I said that I was going to apply an access list, and let's say that I wanted to move a little farther away from my source and get a little closer to the destination. What if I went over here? And I said, well, I'm worried about packets flowing in this particular direction, I could look at things going into the 253 interface or out of the 10.3.3.254. So if I want to get close to the destination, what I might say is, I could say access list, I don't know, 2 permit 10.1.1.1, and that's all that I'm going to do. And then what I'm going to do is, that's all I'm going to do as far as access list commands. But now we have to apply that. So now let's go to interface G0/0/1. That is this interface right here. And I'm going to say IP access group 2 out. Now let's think about what we have here. I have an access list right here in the in direction, and I have an access list right here in the out direction. So let's take a look at traffic from 10.1.1.1. Can I get to the destination? And the answer is yes, because the traffic gets tested in the in direction on 10.1.1.253 and tested in the out direction of 10.3.3.254. But what happens if I go over here to 10.1.1.2? Destination unreachable. Now we got that before, but take a look. This is from another router entirely. It is from router number 1. If we take a look at the simulation and we see where this got killed off, we can see that the traffic made it to router 0, was tested against the first ACL, made it through, got to router number 1, and router number 1 said, all right, wait a minute. You made it into 10.2.2.253, that interface. I've routed you. I've processed my routing table, right? So this depends on where you want to do your processing. And then after processing the routing table, I saw this access list in the out direction, and the answer is no, sir. I'm sorry that is not going to happen. And so this message that's coming back is an ICMP destination unreachable, telling 10.1.1.2 that the packet was actually filtered. Now, what can we do with some show commands? If I do a show access list command, I can see that I've got this access list here, and I've got this particular host with 4 matches on it that was permitted. So this traffic was actually allowed through. If I did a show IP interfaces, and we'll do the one we're working with here, we can see a couple things. We can see that the outgoing access list is 2, right? That's the one that's applied, and we don't have an inbound access list for this particular interface. All right, did you know this already? Questions. Barney is a host with the IP address 10.1.1.1. Hey, sounds familiar. On a particular subnet, which of the following are things that a standard IP ACL could be configured to do? And the answer is that there were 2 things we could do. We could say, I want to match the particular source IP address, or we could do the subnet. We could do both of those with standard ACLs. Which of the following answers lists a valid number that can be used with standard numbered ACLs? Well, with standard, right, remember that there are 1 to 99, and then there's that whole group above that. So the answers were 1987 and 87 were available. Question number 3, which of the following wildcard mask is most useful for matching all IP packets in a subnet 10.1.128.0 with a mask of 255.255.255.0? And the answer was D. We're going to match a whole subnet, or at least a whole class C address space, which is 0.0.0.255. Question number 4, which of the following wildcard mask is most useful for matching all IP packets with a subnet of 10.1.128.0 with a mask of 255.255.240.0? Now, I have this one asterisk because if you follow the rules of the chapter, then the answer would be E 0.0.15.255. But the key in the book says 0.0.0255. Question number 5, ACL 1 has 3 statements in the following order. If a router tried to match a packet sourced from an IP address 1111, using this ACL, which ACL statement does a router consider the packet to have matched? Well, we know the first match criteria. So if that logic says I match that first rule, then I'm going to take it. This rule right here, 1.0.0.0, 0.255.255.255 matches everything from the 1net. So the answer is A, the first one. Which of the following access list commands matches all packets sent from hosts in a particular subnet? But take a look at that mask. It's a /23. So the trick in this question was convert it to a base 10 mask and then see what you needed to do. So that would be 255.255.254.0. And so the corresponding wildcard mask would be B 0.0.1.255. All right, the chapter 3 look ahead. We are going to do advanced IPv4 access control lists. These are extended ACLs, and so we're going to focus on matching some TCP and UDP port numbers. So we'll look at some packet generation and see what we can do, and then we'll do some named access control lists also in the chapter. Well, this has been Chapter 2, IPv4 Standard ACLs. Remember that standard ACLs are the low-numbered ACLs, 1 to 99 are typical. Source IP addresses only. And access lists have really 2 parts. There's the access list rules themselves, the filter rules, and you can have a whole bunch of those, but then you apply it to an interface and direction. And remember that we can use wildcards. You can have wildcards that match a particular host, network, or larger and larger address space, or even complex subnetting schemes. Remember also that all ACLs have that implicit deny all at the end of that. So if the traffic is not permitted, it's automatically denied. Remember also your first match logic. Whatever rule matches first, that's the one the iOS is going to take. And for heaven's sakes, don't forget your interfaces and directions when applying your ACLs. All right, like and subscribe for more security and extended ACLs. May those packets always reach their destinations, no matter what kind of ACLs you're dealing with. And this is CCNA. We're in Volume 2. We're working security. You can do this.